Hey hackers and tech enthusiasts, welcome to Protocol, the series where we unravel the history and mysteries behind the technology shaping our digital world. I'm your host Dade, and today we're going to talk about the Internet Assigned Numbers Authority, or IANA, and how port numbers get assigned as standard for a protocol. When we talk about protocols, it can be pretty easy to make implicit assumptions about them. For instance, as a penetration tester, you might say the client had telnet open to the internet and that's how we got in. And another pen tester might laugh and think about that Hacker Jeopardy team at DEF CON who got the port number for telnet wrong. But how exactly do we decide what the port number for telnet is, anyways? It turns out that way back in 1972, in the early days of the Advanced Research Projects Agency Network, or ARPANET for short, a graduate student at UCLA by the name of John Postel predicted that without a central numbering czar, as he phrased it, researchers could end up with different groups of computers talking different protocols on the same socket numbers. This led to the birth of what would eventually become the Internet Assigned Numbers Authority, or IANA, with John at the helm. Since 1972, IANA has grown from a mere 5 network functions to keeping track of over 14,000 service names and associated port numbers. Not only does IANA keep track of service names and port numbers, but they're also responsible for the global coordination of domain names and IP addresses, among other things. Today, IANA is a function of an American nonprofit organization called Internet Corporation for Assigned Names and Numbers, or ICANN for short. With billions of networked computers around the globe, this coordination plays a crucial role in enabling the connectivity across the internet. Let's pretend that we've developed a super cool new protocol called ProtoChat for people to talk to each other in an encrypted meshnet. We've written all the code to get it working, and our code assumes that we'll be able to talk to other protopals on port 12345. In order to gain widespread adoption of our protocol, we want to make sure people know about it and can rely on discovering other ProtoChat users and servers. Let's get it standardized with IANA so that we become the official service of port 12345. We can submit an application to IANA and tell them our protocol uses TCP and UDP on port 12345. We fill out a bunch of additional information and then we get rejected. It turns out there's already another service, iTalk Chat System, that is claimed to port 12345. But we can have 34521 if we'd like. Without IANA coordinating our ProtoChat port number, our software might mistakenly try to talk to iTalk Chat System computers and things wouldn't work correctly. With our officially recognized ProtoChat port number in hand, we can update our software before we release it to the public. That way everyone running our software can talk to each other seamlessly without having to worry about what port number to connect to. But Dade, wouldn't our protocol have worked just fine if we hadn't requested an official port? Yes. One example of a popular port number that isn't recognized by IANA is 25565, which is the default Minecraft port. Minecraft clients know to automatically attempt to connect to port 25565 unless a different port number is specified, and IANA doesn't have to be involved at all. So why should we bother to register our service name and port number with IANA if we don't need to? It's really more of a courtesy so that network and system administrators can have a shared understanding of system resources. Network administrators can label traffic that's flowing through their networks based on the port, for instance. And firewall administrators can use well-known ports to explicitly allow or block traffic known to be used by particular technologies. Application developers can even use these default ports to ensure their applications can communicate with other services on these default ports without having to ask the user to specify. But in my opinion, I just like that when I see certain port numbers open, I automatically associate them with certain services. When I see 23, I know that's probably Telnet, and when I see 22, I know that's going to be SSH. Some examples of well-known ports that we use every day include port 80, HTTP, port 443, HTTPS, and port 53, DNS. We don't even know that we're using them most of the time. When we type youtube.com into our web browser, we don't have to specify what port we want to connect to. The browser makes an assumption to try to connect to port 80 or port 443 automatically. The browser even knew automatically to use port 53 to request an IP address for the youtube.com domain name. These well-known ports allow users and systems to more easily communicate with one another without having to be ever vigilant about remembering which port number to use. In addition to managing a list of service names and their associated port numbers, IANA also maintains other registries, including the Universal Resource Indicators, or URIs, and media types, such as text/HTML. These resources allow developers, network admins, and even users to more effectively communicate with computer systems. For instance, in order to make sure that your web browser opens a link you click on, developers will prefix the link with http://. This is commonly accepted standard to tell the web browser to attempt to use the HTTP protocol to communicate with the website. Similarly, a web server might tell your browser that the file you requested is a PNG. That way your browser knows that it should render the image rather than attempting to display the contents of the file as a plain text. We'll likely encounter many other URIs in future episodes, as some protocols make extended use of them. In some ways, URIs are sort of like a protocol of their own, typically used for the sender to convey to the recipient some program to use in order to establish communication. Without a central organization for helping to coordinate and standardize port numbers, URI schemes, IP address allocations, and domain names, our devices would not be able to connect with each other nearly as seamlessly. Imagine having to remember that you want to visit 93.184.215.14 on port 443 in order to see the standard documentation example website. Thanks to IANA and our friend DNS, which we'll cover in the next episode, we can simply type example.com into our browser and it'll figure out the rest automatically. In coming episodes, we're going to switch from meta protocol topics to looking at specific protocols in more detail. We'll still be interweaving meta topics throughout the series, so if you're curious about how IP addresses get assigned, why some ports require you to be a root user, or what the heck the OSI layer is, stay tuned. Do you have a protocol you'd like to see a video on, a protocol you want to know more about, or maybe a deep dive into the politics behind protocols? Let us know in the comments down below. If you're interested in seeing more of this series on protocols, give this video a thumbs up and make sure you're subscribed so you can get notified when the next episode goes live. With that, I've been Dade, stay curious and stay connected.